Uh, so I think we'll just start with the session, and I guess others might join like as the session goes on. So I guess we can actually start with the session because around 15 people are here. So yeah.
ഇതെങ്ങനെ ഓഫ് ചെയ്യുന്നത്? ഇതെങ്ങനെ ഓഫ് ചെയ്യുന്നത്? ഇതോ?
Hello.
Yes.
Yes, sir.
Yeah.
So let's start the
Yeah,
session.
yeah.
We have.
We can start. We can start.
Yeah, sure. Sir. Okay. So yeah.
Is there a formal speech or something like that, or shall I directly?
No, sir. We can begin with the session directly.
Directly. Okay. Okay. Fine.
Yes.
So, good evening, everybody. I am Dr. Sudheep Elayidom, professor in Department of Computer Engineering. So, good evening, all. I am Dr. Sudheep Elayidom, professor in Department of Computer Engineering, Kochi University of Science and Technology. My research area is actually data science, big data, cloud computing, machine learning, and so on. I had the opportunity to award three PhD students under my guidance. So I take this opportunity to thank Utkarsh Raj, who is my student in the 6th semester, who invited me to take a session in this particular seminar. I thank him, and I'm very yeah.
Thank you, sir. It's an honor to have you among us.
Okay. Thank you. And I also thank the organizers of this function, like Arya and whom I just met today. It is a great initiative from the student community, in fact, because when we were studying, such an initiative was not there. Now, because there are a lot of online facilities and all, there are a lot of ways to get knowledge from this during this COVID session. And the way I have organized this particular session is like, it is a very, as you know, it is a very vast topic. We cannot even dream to cover deep learning concepts and advanced deep learning concepts and all within a very short span of 1 hour. So what I have done is, actually the topic today is mainly how to convert to research. So my main focus will be to how you can convert your ideas to research papers, how to draft a paper, where you can present it, how it is beneficial to your career, what is research, and so on. But before that, I will give a very brief introduction to the current research trends in the area of deep learning. That is my plan. Okay. So, as I have already pointed out, it is a very vast area. I may not be covering mathematical details, though I have prepared for it, but this session is not intended for that. Mathematical implications, it will take a lot of time for that. Later, if you drop me a mail, I can give you the references, explanation, or through a phone call, we can solve your doubts and all. Today, only concepts will be there. Concepts. It is very, very important, because from concepts, basic concepts only, you will be able to arrive at some good real life problems, and you can draft your own project proposals. You get a project idea from project proposals, isn't it? So from these concepts only, you can make project proposals. So this is a concept level presentation. At any point during the session, feel free to interrupt me with your doubts. And at last, we will have a question and answer session, or after the session is divided into 2 halves. For the first approx 30 to 40 minutes, we will have the basics of deep learning concepts discussion. Either after that or at the end of the seminar, you can ask your doubts, or during the seminar, feel free to interrupt me. The second half will be how to do research effectively, how to publish effectively. That will be the second half of the seminar. Okay, so thank you, and I'm proceeding to the slides.
Yes, it's visible.
Yeah, it is visible. Yeah, so the contents, actually, I have got a 100th slide preparation, because nowadays there are 10 most popular deep learning models. I told we don't have the time to cover them all. So I will be covering, out of this 10 lists, CNN, RNN, bidirectional RNN, sequence to sequence, LSTM, autoencoders, and GANS. Just the basic concepts. All others, I will give you the references where to refer, and so on. So as you know, deep learning is coming under the big umbrella of artificial intelligence, as the diagram says. Artificial intelligence is the ability to for computers to be intelligent, isn't it? Machines to be intelligent. That is artificial intelligence. And below that, we have machine learning, where you have got your machine learning algorithms like pattern recognition algorithms, classifiers, and so on. Data sciences, all these things comes under machine learning. And below that umbrella, we have got deep learning. So deep learning is more concerned with advanced classification and machine learning programming. So fundamentally, this is the idea of what is deep learning. It is a basic neural network. It has got a classification problem. If you give a dog, it will say it is a dog. If you give it a cat, it will say it is a cat. So it is a classification problem, a multi-layer perceptron. You have seen the fundamental idea. The course has a prerequisite that you are familiar with the basic concepts of neural networks. The course has got a prerequisite. But I will try to be as much simple as possible in my lecture. I will try for that. And at any point of time, feel free to interrupt me with your doubts or whatever it is. So this is the fundamental idea of deep learning. You have got a simple neural networks. The idea of the neural networks is it will learn. It will learn from the input, and it will try to classify from the input. It has got 3 layers: input neurons, 3 input neurons, 1 hidden layer, and 2 output neurons. The hidden layer learns. There are interconnection weights, and these weights are adjusted using the backpropagation. The whole idea of learning of a neural network is computation of weights automatically. So the popular neural networks are feed-forward neural networks, regression and classification problems. It is used. Convolutional neural networks, image recognition, deep neural networks, acoustic modeling, and so on. And it is also used very much in image classification also. Recurrent neural networks for speech as well as text recognition. So it's an important slide. What you can think is, whenever you nowadays, when you refer the internet and all classifieds, you have got CNNs, RNNs, and so on. Whenever you hear the learn convolutional neural networks, you can basically think it might be an image processing application. Mostly CNNs deals with images, whereas RNNs mostly deal with NLP and text mining. So whenever you are having a text analysis, natural language processing, such type of application, you go for RNN. Deep neural network is, you see, it is also a type of CNNs and RNNs are both a variety of deep neural networks itself with many layers. When a basic neural networks are having many layers, it is called deep neural networks. Till now, if you have got any doubts, please feel free to interrupt me. Till now, any doubts, feel free to interrupt.
Guys, you can also put your doubts in the chat box. I'll read them out to sir. Yeah.
Okay, fine. So I am proceeding. So CNNs, as the name suggests, convolutional neural networks. It has got many layers, which will be explained in the coming slide, called convolutional layers, pooling layers, and flattening layers. It is mainly used for image classification types of problems and image recognition and analysis problem. It is also called convnet, convolutional neural nets. It is used in computer vision tasks. What is computer vision? Giving vision to computers. That is called computer vision. When computers can see, hear, etc., like human beings, such research area is called computer vision. So we will try to understand CNN with an example. It has got a convolution layer. What is happening in convolution layer? I will explain with an example soon. Then it has got a pooling layer. I will, when you see an example, you will clearly understand. Then flattening and full connection DNA networks. Now let us see a simple example. You see, as you know, images are represented using a pixel, isn't it? 111, 011, 001, etc. The filter or kernel uses as mask. They are used as mask. For example, suppose you want to write the letter 9. Suppose you want to write the letter 9. You have got, you see, many curls inside that. The tail of 9, the round part of 9, and so on. Okay. So for every part of a particular image, you can, to know its presence, that is, suppose you have a figure of a, you see, monkey. As you know, if you want to identify presence of monkey in an image, as you know, monkey has got ear, monkey has got a tail, monkey has got eyes. You can create filters or masks for eye, nose, tail, etc., and do the convolution operation as shown in the coming slide to see whether it is present. Let us see an example. You see, suppose this is the mask. You see, you can see in the previous image, this is, suppose this is the mask. On the right side, you have got the mask for the, say, ear of a monkey. And the left side matrix is for the complete monkey image. So you have to locate the position of the eye of the monkey. what you will do? You will do the convolution operation as shown here. You just put it over the side. You can see the first 3 by 3 matrix on the left side. You look at the diagram. What you do? You do the you see AND operation, 1 into 1 plus 1 into 1. What is that 1 into 1? You see it is positional correspondence. This one into right side 1. Then the next one into the next 0. Like that you put into operation and add them. So, and when you add all of them together, you will get 4. I will explain once more. You look at these two diagrams. Element number 1, 1 of the left side and element number 1, 1 of the right side. Multiply them. 1 into 1 plus 1 into 0 plus 1 into 1 plus the second row we take of both the matrix. Take the second row of both the matrix, multiply and add. 0 into 0 plus 1 into 1 plus 1 into 0. Like that, when you add, you will get this particular value 4. Any doubts up to this? Any doubts?
Yes, and there's no doubts. We can.
Okay, fine. So like that we proceed. Like that we proceed for the, you can see that the masks are moved like this. See the masks, the 3 by 3 metric mask is moved through all the positions of the image to populate all the parts. And you can see that the image is populated. Sorry, the mask elements are now computed as 4, 4, 4. You can see that in the diagram. This is the essence of the convolution operation. This is convolution. And after that, you do an operation called the ReLU. In ReLU, what happens after applying the filter? Sometimes you may get some negative values. In order to slice all the values in the range 0 to 1, only in the positive range, the slicing function, we use ReLU. ReLU function has got a property. It will slice up all the values only in the range 0 to 1. You can see the negative values are now converted to zeros and all others are now put into 1 or 0 to 1. Yeah.
Sir, excuse me, I have a doubt.
Yeah.
Sir, how will we get negative values? We are just multiplying and adding it here.
That is in certain filters you will have negative values. In certain when you have certain filters, you will have negative values. That's it. Okay. Yeah.
So Rajat has a question. How can we decide the size m into n of the mask for a given image?
Yes, that is also done during the training phase. That the programmer need not worry. CNNs during the training process itself will learn. That is the beauty of convolutional neural networks. All these things CNNs automatically learn during the training. Okay. Now we have got pooling. In pooling, what happens? In pooling, what happens is, suppose you have got a figure like a very low, even after convolution, you have got such a figure. And suppose you want to reduce the size once more, you go for max pooling and average pooling. In max pooling, what happens? You take the maximum value. And in average pooling, you take the average value. You can see in this 1331, and which is the maximum value? It is 3. And in average pooling, what happens? You get 2 as the average of 1 plus 3 plus 3 plus 1. Okay, that's it. And after pooling, after max pooling, you get this support. This is the pooled feature map, and you flatten it like this. You flatten and you get this figure. And this flattened image only, you give it as an input to a deep neural network. This flattened image only you give as a neural network. To learn more, this is how you classify the image of 9. From this figure, you can analyze that 9 is having a round shape, a corner shape, many shapes you can see in the figure. Each of them, as somebody asked, each of them will have separate masks. And when I read the literature, just like you asked, how that mask values are computed, for that also there is another training phase. That is what I read. That is to decide what will be the mask value for each of them. You can have another training for a CNN. And the mask values for each of the filters, for each of the shapes are computed like this. And for every shape of the loop circle, vertical line, diagonal line, you do the computation and you identify 9. You identify 9. And this is another example called the koala animal. You see, I very much like the YouTube videos of Code Basics by Dhaval Patel. I hope you all might be fans of him. He's one of the best vlogger I like very much. I strongly recommend you to follow his slides, his YouTube videos to get very deep concepts. In fact, you can see many overlaps from many YouTube videos because I read lot of YouTube videos and learn from all those videos, research papers and so on. And I very strongly recommend the students to see such videos. Only when your basics are correct, you can read research papers and do effective research. So in one of the videos from Code Basics, he has given an example of identifying koala animal. You see, just like this, in the convolution plus ReLU layer, you can have masks separately for eye, nose, ears, etc. Just like you compute the vertical line, horizontal line masks for 9. And after that you compute convolution plus ReLU and then you pool it. And then you give these inputs, the flattened input for ears one at a time, for mass one at a time, and identify a koala. This is how convolutional neural networks are coming. And the main applications of CNN are machine translation, named entity recognition. This is one of the very popular thing. What is named entity recognition? Suppose I have got a task. Like labeling a sequence of text. For example, Sudheep teaches Utkarsh. And I want to tag the sentence like Sudheep is to be tagged as teacher and Utkarsh is to be tagged as student. So the entities called Sudheep and Utkarsh has to be identified as teacher and student. That itself is a named entity recognition research work. So please understand that named entity recognition, image classification, object detection is a very hot research area nowadays. I have got many research scholars who work in the area called object detection under me. For example, identify malignant cells, cancerous cells in an image. It's a very hot research area. If you can detect cancer at a very early age, you can detect it much earlier. So CNNs are very much used in object detection, image classification, just like we saw now, the koala and the 9 example, and named entity recognition also like that. Okay, so this is the concepts of CNN. So any doubts up to this?
Rajat has a doubt. So,
Yeah.
will reducing the size of an image matrix by mask and pooling will not lead to loss of information of image?
Loss of information of it, that itself is another area that we will be seeing in the coming slide called the autoencoders and all. That is, we can definitely compress without losing the size of the image. We can compress it in different ways. We will see as the class progresses. Okay, called autoencoders and all. We will see that. So Utkarsh, shall I proceed to the next?
Yes, sir.
Okay. Next one is the recurrent neural networks. In recurrent neural networks, I will just say the concept because I'm losing time because we have got only 1 hour. This is the idea of recurrent neural networks. Here, what happens is when you have got sequential input to be classified, or when you have got a time series input, we go for recurrent neural networks. Many students have got a confusion that RNN is also a neural network concept in which you have got many layers. But when you look at this diagram, even if it is shown as separate 4 areas, it is not separate 4 layers, it is separate 4 timestamps. For example, you have to understand the concept very clearly. When I want to give an input like the share value of Infosys is 7 rupees in January, 8 rupees in February, 10 rupees in March. So the first input is 7 is to be given in the timestamp 1. You can assume that is our x0 in this diagram. That is one input. x0 is its output. So the fundamental idea of RNN is that it allows sequential input to be processed, and it has got a memory aspect also. It has got a memory aspect also. It remembers the previous input. For example, if when I say I ate an apple, when an apple input is coming, it remembers the word ate also from the previous output. So RNN has got an inherent memory structure also. That is the fundamental difference. And what are the applications of RNN? RNN can be used for as a one-to-one concept in machine learning problems. Okay, and it can be also used as a one-to-many, that means image captioning applications. What is image captioning? Suppose one input image is given, captions are automatically generated. For example, when I present an image of you see a person playing football, suppose I have got an image with 2 objects inside that, person and football. A caption will come saying person with football. So that is called one-to-many recurrent neural networks. So I will give doubt clearance sessions finally, because we will lose a lot of time, because I have got the full portion of research paper writing pending. Next is many-to-one. Many-to-one means, another example is sentiment analysis. Sentiment analysis means many-to-one. You see, suppose, you see, nowadays there is an area called product reviews. Product reviews means I have got a very long text of product reviews. For example, last week I have bought, and suppose Oppo F19 mobile phone. In that Amazon website, there will be many reviews that are coming with respect to the Oppo mobile phone. So you can analyze them to be either positive or negative. Either positive or negative. So sentiment analysis is nothing but why it is called many-to-one. You have got many reviews coming, and output is just whether it is a positive review or whether it is a negative review. And another very useful thing is called machine translation. I will show you a slide for machine sequence to sequence model. You see, sequence to sequence model. This is sometimes called encoder decoder model, because our discussion is just at a black box level. You see, it has got lot of mathematical concepts behind that. Personally, I have I have prepared all those but we don't have the time to discuss, clarify doubts and all. It may take approx 10 or 20 sessions to discuss the theory behind that, what is softmax and all. But you just understand that one of the very hot research area using RNN is machine translation or sequence to sequence model. You can see that it is an English to German translation. You can see that one set of RNN acts as an encoder thing, and another set of RNN acts as a decoder thing. So RNN can be used as an machine translation from English to German. That is why it is called as many-to-many model. Then you have got another variant called bidirectional recurrent neural networks. In this, just like before, you have got memory in the forward direction, you can have a memory in the backward direction also for better prediction. For example, I ate mango dash. When I say I ate mango dash, and I want to predict what will be the next sentence. So for that, what can be the next sentence? Yesterday or today can be the next sentence. So to predict that, you can move in both directions. I ate mango one at a time, and mango ate I in the backward direction. So that makes your predictions in a better way. And another thing is, another highly mathematical stuff is called LSTM, long short-term memory. I will just tell what is its concept, and we'll give you one of the excellent paper based on that. Let us first of all understand the basic concept behind LSTM. Suppose there is a sentence called Anil loves dosa every day for his breakfast, and it indicates he likes dash cuisine. So what you have to do? You have to predict what is the next term after he likes. One of the best examples for RNNs is autocomplete. One of the best examples for RNNs are autocomplete. For example, when you type an email in Google, you see when you write something like, good morning, sir, how are? When you type how are, you will be autocomplete. Please understand, autocomplete and all are typical applications of deep learning models. RNN, LSTM, these are all GRUs. All these things are running behind Google's autocomplete mechanism. So this is how it works. Anil loves dosa every day for his breakfast. It is a very long sentence, and you want to predict what comes after he likes dash. So you have to remember the word dosa, and because it is dosa, it should predict Indian cuisine. Similarly, in the next sentence, but his brother Ajit loves pasta every day for his breakfast. Indicates he likes Italian cuisine. So he likes dash cuisine. So if you want to predict Italian, you want to, because it is pasta, you will predict it is Italian. So as a summary, when you want predictions in long sentences, in the case of RNN can be, because its memory is just short. Its memory is short only. So for short predictions, you can go for RNN, and for long predictions, you can go for LSTM. Why it is called long prediction? It has got a long-term memory as shown in the next diagram. I will show the next diagram. You can see that this sentence called Anil loves dosa every day for his breakfast, and it indicates he likes Indian cuisine, is a very long sentence. So when you want to predict after he likes, you want to remember the word dosa, which was shown at the beginning of the sentence, which is very long. That is why LSTM comes with two types of memories, long-term memory and short-term memory as that of RNNs. Okay. So you can see that when you want to predict Indian, you can see that till you predict Indian, dosa is in long-term memory. The moment it has predicted Indian, dosa is forgotten. And when the prediction Italian comes, you can see after that, your long-term memory is pasta. It is not pista, it is pasta. Okay, and you can see that the old long-term memory is gone. So you can think like actually the mathematical notions, we don't have the time, you see, very complicated mathematical notions are there. So if you are interested to go to in-depth mathematical notions, in fact, I have read this full paper. I have taken the pain to read the full paper by Christopher Olah, because it is my research area. We don't have the time to refer all these things. You can note down this name, Understanding LSTM Networks by Christopher Olah. The link also is there. You can search in the net.
Sir,
Yeah.
I would just like to point out one thing. All these resources, which like the links and everything, I'll be putting it in a GitHub repo, and so I'll put a feedback form just before the end of the session. So fill it out so that I can send out to your all the resources which have been used. Yeah.
Okay, fine. Okay, fine. So that's it. Now we go to another model called generative models. In generative models, what we do is, you see, you have got autoencoders. Let us see the intuition behind autoencoders. See, it is like you want to learn about an image. You want to learn about an image, and you don't have the time to read everything about that image. You don't have the time to read everything about that image. So you go for a reduced version about that image. That is the whole idea behind autoencoders. And that is the intermediate compressed version, which you can see. I will repeat once more. When you see the intuition behind autoencoder, you will understand. You see, this is the intuition behind an autoencoder. An autoencoder can be trained with the same input and output image to generate a compressed bottleneck representation in between, as shown before, which can be used later as a compressed form of image in classification. That means, you see, all of you, I have already told that to have, you see, the basic concept about the dimensionality, you see, of the data mining, data pre-processing is a prerequisite of the class. So those students who have studied data mining in my class already might be knowing about the dimensionality reduction principles using chi-square, principal component analysis and all. Now, the concepts like principal component analysis, chi-square, etc. are computationally very intensive. Principal component analysis, chi-square, etc. All these things are computationally intensive. Whereas if you use autoencoders using deep learning, the dimensionality reduction can be done much easier. How you do that? You give the same input image as the input and output to an encoder-decoder network. Just like in this diagram, the network will adjust its weights in such a way that as an intermediate level, you will get a compressed representation, a reduced dimension representation of the original image. That is, and that particular reduced dimension can be later used as input to your classification problem. Typical example is image coloring. You have got a very complicated image, and if you want to reduce, you can reduce using the concepts of autoencoders, and you can use for coloring, feature variation, denoising of image. Suppose you have got a lot of noise in an image, using autoencoders, you can have a reduced representation and you can remove the noise, because the reduced representation will be devoid of noise. That is the concept behind the autoencoders. And now you have got the GAN networks, generative adversarial networks. Generative adversarial networks. Here the idea is a very original idea. In research, what do you call as original ideas? Original idea means a path-breaking idea which has not been discussed much. It is a fresh idea to solve a problem. So GAN networks was developed, in fact, you see, by Ian Goodfellow in 2014 in his original paper. Ian Goodfellow in 2014, he proposed this particular idea, and this is how does it work. You see, this is like a competitive model. What is a competitive model? One network will keep on generating fake images, and another model will keep on identifying and classifying them as real or fake. I will repeat once more. In the case of GAN networks, what is happening? Our goal is, you see, to distinguish whether an image is fake or not. That can be one task. And another is to create another image like this also. That can also be like that. So what does the generator do? Given the some sample inputs, generator will generate some fake images. What does the discriminator do? The discriminator will take the inputs from the generator and it will decide whether it is fake or real. And if the discriminator can decide it is a fake image, so the generator has failed, and that information is given for retraining by the generator. So what happens? Generator will learn his false samples and false learning. Discriminator also will understand where he failed to identify real. So it is the generator and discriminator will fool each other. Generator and discriminator will fool each other and try to improve its classification process. So this is called competitive learning. So I will read out, this is how does a GANS work. In GANS, there is a generator and a discriminator. The generator generates fake samples of data and tries to fool the discriminator. The discriminator, on the other hand, tries to distinguish between the real and fake samples. The generator and the discriminator are both neural networks and they both run in competition. That is why it is called competitive network with each other in the training phase. The steps are repeated several times. And in this, generator and discriminator get better and better in their respective jobs after repetition. Now, what are the applications of GANs? Prediction of next frame in a video. This we have seen in a lot of puzzles, isn't it? Somebody is playing cricket, and what will be the next shot in the cricket bat? In my childhood, I remember in Sports Star, there is a magazine. A batsman is doing a shot in cricket. Where is the ball now? Or what will be the next frame? In order to predict this generative network can create new images, and like that you can learn. Then text to image generation, enhancing the resolution of the image, and image to image translation. Suppose you have got a real image of a zebra, from the zebra you can fool, or you can create another image with the same thing. You can generate that of a horse. So many types of applications this GANs are having scope. And so this is in image translations, object detection, and so on. So now I am proceeding to the research aspects, because it is now almost 45 minutes. It's almost 45 minutes. So I will consolidate whatever things we have discussed now. Till now we have seen what are the various advanced models in deep learning, like CNNs, mainly for image classification, image analysis, pattern recognition, and object detection. Then we have seen, let us go through the slides itself. Let us just try to recollect through all of them. Yes, applications of CNN we have seen. CNN can have a one-to-one translation, you can have a one-to-many, and we have seen that named entity recognition, image classification, object detection, etc. are some of the major applications of CNN. Then you have got recurrent neural networks, and we found that it is very much useful in image captioning. It is very much useful in machine translation, as we have seen in this particular example of English to German sequence to sequence models. Then we saw LSTM, long short-term memory. It is useful for translating very long sentences like this. You can predict the next sentence from a previous word. For that, you can use LSTM. Then we saw generative models or auto-encoders. We saw the main applications of auto-encoders. The intuition behind auto-encoder is that it can be used for reduced representation of an image, and that reduced representation can be used for further classification, image classification problem. And then we saw the adversarial networks, called the generator discriminator network. It can be used for image generation, image coloring, identifying next frame calculation, and so on. So these are some of the hot research projects or hot research areas that nowadays deep learning works on. So till now, at the concept level, if you have got any doubts, you can ask. Till now, in the concept level, if you have got any doubts, we can ask.
I think I guess there is no.
Okay.
Yeah, so we can
Now,
actually
I am now
start.
proceeding to research. Okay.
Sure.
Okay. Just let me take my specs. 1 minute gap. 1 minute gap. Okay, Utkarsh. Just
Yes,
1 minute.
yes, sure.
Yeah. Utkarsh,
Yes, sir. The screen is visible.
the screen is visible in the full mode itself.
Yes, sir.
It is visible. Okay, fine. I don't know what is happening. Just let me. It's not moving. The slides is not moving. Just let me look once.
Sure.
Okay. Now it is moving. The slides are moving, isn't it?
Yes, sir.
Okay. So this, even though I term it as research, these are all very, very important tips for, because all of you, I know that many of you are planning to go for higher studies in United States, UK, for higher studies, etc. And many of you are planning to do for campus placements and in multinational companies. So these ideas will definitely help you to be a better researcher or a software engineer. So the agenda of the session is like this: what is and why do one research, broad areas of research in computer science, research methodology and introduction. I am not going to details. Okay, these are all high-end PhD topics, highly deep topics. I am not going because very few might be going for PhDs and all. So just keep in mind all these tips. That's all. I may not be going into depth because this itself is a separate seminar. These slides are directly taken from the slides which I have given to a university before. And how, what is a publication, what are good and bad publications, and so on. What is and why do one research? Okay, please understand that research is a word that is originated from the word called research. Research means again and again search for knowledge. Okay, for example, you see, I have got many types of research scholars who do very quality work, as well as those who do, you see, just some basic work. I always say to them that even if you study from the basic knowledge, that also is something valid, because when you do research, you read a lot of uh, YouTube videos, literature, journals. You read lot, so that also is a research. Doing a vigorous literature review. What is literature review? Actually, PhD work or research is actually developing something new. Developing something new which is not already existing. If you want to develop something new that is not already existing, you have to know what is already existing, isn't it? Then only you can develop something that is not already existing. That process is called literature review. And developing knowledge around a baseline and contributing to society to help solve. You see, this is a mistake usually all students do. Generally, PhD scholars or MTech project people, just they want a degree, just they want a doctorate, or just they want to do some project. That's all. That's not enough. Whatever you do should be translated to society as a product. Whatever you do should be translated to society as a product. So that commitment should be there in the research. What are the broad areas of research in computer science? Machine learning, data science, NLP, image processing, network security, and so on. Okay, big data analysis, deep learning, which we discussed. Lot of research areas. And research methodology I'm not touching. But this is important because our agenda is turning a machine learning project into a research paper. This is how a research paper looks like. It should have an abstract, because what is a research paper? First of all, let us see. A research paper is a byproduct. It is a byproduct of a larger research work. When you do a research work, there will be a lot of byproducts, isn't it? Suppose I am doing a data mining project. It will have data pre-processing part. It will have data collection part. It will have data classification part, and so on. So each of them can be a candidate for a research paper. So that is the part that is coming under abstract. And background of the problem. Okay. Abstract means it is a brief description about the paper, what the paper is doing, background of the problem, why I attempt this particular research work. Introduction. Here we do something called as citations. What is a citation? Citation means, citing of a paper means, suppose I have written a paper, the quality of a researcher is judged by how many people in the world is referring your paper. Okay, if you go to Google Scholar and see how many people are reading your paper, there is an index called H index that shows the quality of a researcher. Okay,
So that is coming under what? Introduction. In this paper, which all papers you are referring? That is coming in the introduction. Review of literature, I told. Before you do a research, you have to review the literature very carefully. You have to review the literature very carefully. Because you have to read minimum 50 to 100 papers. You have to, in order to do a PhD work in, say, in IIT, you have to read minimum 50 to 100 research papers. Then you have got the methodology. Then you have got the analysis. What are the results and discussions? What is the specific output? Whenever you go for a research or a research output, it has to be specific. For example, when people are doing nowadays, a lot of researches are happening in COVID-19 predictions. COVID-19 predictions. So, in COVID-19, what exactly you are trying to predict? What exactly you are trying to predict? That is coming under what? The problem statement of the research work. Are you trying to predict the future output? Are you trying to, you see, in which month's COVID curve you are trying to predict? So the problem statement of a research work has to be very specific. And this is a very important concept you have to understand. There are two types of publications, research publications. You see, what is a research paper? We have seen. A research paper is a byproduct. A research paper is a byproduct of a research work. So there are two types of research publications, journals and conferences. Journals means high quality publications. For example, IEEE transactions, InterScience, Elsevier. These are all, yeah.
Sir, could you just move your mic a little bit away?
Okay. So you have got different types of journal publications. You have got IEEE transactions. IEEE transactions means, you see, one of the highly prestigious publications. If you have got your publications in IEEE transactions, usually when we evaluate PhD thesis, we just look at the backside of the thesis, where this paper is published. If the paper is published in a quality journal like IEEE transaction, the chances of accepting the PhD thesis is very good. Okay, so that is the thing behind journals. So usually journals are very difficult to crack. To get a paper in an international journal of high repute, it is very difficult. Like IEEE transactions, Springer, Elsevier, all these things are difficult. Whereas to get a paper in a conference, what is a conference? Where you can go and present your paper actually. In the case of journals, it is not a must that you should present your paper. You need to upload to the journal, and you can it will be reviewed by 3 people and you will be getting the answers. Whereas in the case of conferences, you see, you have to actually go and present. Typical example, International Conference on Machine Learning at USA 2021. IEEE Explore, Springer Link, these are all sometimes the papers that are presented in a conference. Can be indexed by prestigious publishers like IEEE Explore, Springer Link, and so on. So how to judge whether a conference is good or bad? You have to just check where it is indexed. If the conference is indexed by IEEE Explore, it's a good conference. If it is indexed by Elsevier Procedia, it is a good conference. And there are many advanced things which may not be useful at your level called patents, IPRs, etc., which are very, you see, the best indicators of a quality research of high repute. Patents, IPRs and all, these are all beyond the discussion of this particular seminar. UGC care list, how you can judge whether a journal is good and bad. Government of India has listed a list of journals to be good quality. For that, you have got a UGC care list. UGC has accepted certain journals. These are some good repositories of research papers. I will suggest, I know that there are many students in the class who want to do quality research. That is, when you are in the 7th semester, many of you might be, you see, doing, planning to do quality research. And I suggest you to read the, you see, such research papers and then land on to your problem. Like IEEE Explore, Google Scholar or Science Direct. First, read those papers and come back to your research work. That will be wonderful. Suppose you are doing a project in deep learning. You read some papers in deep learning and come back. That will be wonderful. So these are some repositories for datasets called UCI datasets, Kaggle, KDD datasets, and so on. So what are the tips for quality research? Read, read, and read. Starting from ebooks, Google Scholar, to high quality papers. Minimum 50 to 100 papers are needed. Okay. Choose your research topic based on interestingness and passion. Choose your research topic based on interestingness and passion. It should be useful for the society. It should be accomplishable. And you should choose the research area based on availability of the expertise. And it can be intuition driven also. Because if you have seriously listened to today's class, and if you're serious in your approach, I'm sure that you might have got a lot of research ideas from today's class, today's seminar. For example, you see, you can think about image caption generation. It's an idea you got today, image caption generation. So in order to do that project, what you should do, go to IEEE Explore and download papers that does image caption generation. Try to contact experts who have done proven work in that area. And try to refine, make a good design. Students have a tendency to directly dash into the coding. Rather than that, have a design, a proper design after reading the research paper. Please understand that research papers are nothing but consolidation of ideas. It does not have implementation. So the main ideas of guides like us, we people are more concerned at a concept level. Implementation level is mainly the duty of the PhD scholars or software engineers. What we do, we tell them what to do. We tell them, you look there. You see, in English, there is a proverb, guides show only the torch to a path and they never walk. What the guide or a teacher will do, the teacher can show the path, or he can show the light only. It is you yourself have to walk through that path and accomplish the goal. So today, my idea was to give you some tips like this. You can do RNN-based projects on image captioning. You can do projects for sentiment analysis. You can use advanced techniques like AUTOENCODERs for dimensionality reduction. You can use LSTMs for auto-completion type of problems. You can use RNNs for language translations. You have got lot of project ideas from this session, which was the goal of this session. How to do is not goal of this session because it may take a lot of time. That is why I was not taking that much time to discuss much on the mathematical aspects and all. That is, for that we may have to have a separate session for that, going into depth of that, solving each of that, and so on. This is a concept level, problem level, or a black box level discussion where many thoughts the teacher or the guide can throw to your mind. Now you can research, go through those repositories and download those papers and arrive at your own problems. So these are all GitHub, as you know, is a repository of all you see wonderful code. You see, image captioning, you just go to GitHub, you can get the code for image captioning using RNN. That is why we guides are not at all worried about the implementation part, because you will get a lot of tailor-made code, image captioning code to implement AUTOENCODER. You can download from GitHub and go to Google Colab and execute. You will get a lot of tutorials. It is just a matter of understanding the videos and do everything by yourself. So implementation is not the actual problem. You can learn anything by yourself. It is not at all a problem. The real issue is to arrive at a clear problem definition. That is sometimes called as hole in the literature. What is a hole in the literature? Whatever is that is existing and whatever is not existing, that is called as the gap in the literature. So some interesting research problems that you can think, you can carry on or carry forward as your S7 projects or your industry projects or your startup ideas are these things. Okay, CNN and RNN architectures, their parameter tuning for deep learning to improve their accuracy, time series analysis for the share market. Please understand that the share market variations are nowadays a very hot research area. And GANS, gated area networks, are, you see, another research area we have seen now. The competitive networks. Text summarization is another very hot research area nowadays you can use. Then security enhancement using blockchain and all. These are all hot research things. So we have shown what all things we have seen. We have seen why do one research, we have seen. Broad areas of research in computer science we have seen. Then research methodology, because I have not touched that because that is beyond the scope of this class. Research methodology is a pure PhD area. I am not touching that. Structure of a typical research documentation that I have seen. Avenues for publications. What is an avenue? Journals or conferences. How to decide good and bad avenues. What is a good journal and which is a bad journal? We have tried to identify that. Tips for quality research publications, that also we have seen. Like you see, you have to choose a good research problem statement, you have to choose a good avenue, and so on. And some interesting research areas and problems we have discussed. Now we go for a discussions and question answer things. If there is any pending questions or any discussions, if you have, you can ask.
Guys, before we start with the Q&A round, I would just like to point out that I upload all the resources and everything as I told before. So I have put the link right now in the chat box. So just keep an eye for it. I'll be updating everything, the whole session video and the PPTs and all the resources sir has used during the session. So just keep an eye for it. Yeah, and now we can have questions. You can either type it out in the chat box and or unmute yourself and speak up.
Dr. Sudheep, Mahesh here.
Yeah.
Thanks for the nice presentation, and I think it the basics, and it will help maybe students to go
Thank you,
for
sir.
research. Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Sudheep, one challenge maybe the people in industry facing is actually, so they are not aware about the research process and research methodologies. I think your introduction session gave and maybe like how to approach it. But
Yeah,
my
yeah,
basic doubt is actually most of the research papers, if you see,
yeah,
there is a lot of mathematics.
yeah.
That may be the struggle where I think the people in industries are reluctant, or not much papers are coming from industry.
Yeah,
So,
yeah, yeah.
so do you
Sir,
have any
uh,
suggestions?
sir, first of all, I would like to know more about you, sir. You are from industry, actually.
Yeah, I'm from industry,
Uh,
and
s-
I'm around 18 years in industry now.
oh,
So
very
I'm
nice.
into
Sir, which is your
mathematics.
company? Which is your company?
I'm in Infosys.
Oh, great, great. Okay, fine. Oh, very nice to get introduced with you. Anyway,
Thank you,
okay.
sir.
Sir, your specific question is like, um, you see, how to understand the mathematical notions in the academic research papers, isn't it?
Correct, correct.
Okay. Sir, for that, you see, what I suggest is when you look at in the case of you see support vector machines, machine learning, and so on, there will be some fundamental mathematical areas like regression. For example, if you take machine learning itself, there will be something like probability distribution. So, or when you look at the research paper, they will be starting directly from probability density functions or Gaussian distribution and so on. So, what you have to do is you have to start from the basics. When you say Gaussian distribution, there will be probability density function. Then we have studied probability density function in our +2, isn't it? So for you have to go to that particular what is probability density function in Wikipedia, or there are some good ebook references like statistics in machine learning. I would strongly suggest you to download an ebook from Springer. There is an ebook in Springer which goes like this: Statistics in Machine Learning. If you download that, it has got all the basics of statistics that is usually seen in machine learning problems. So there will be the basics of probability density functions. There will be basics of Gaussian distribution. There will be basics of principal component analysis. And from only after the basics are okay, you can read all those research papers and try to understand. That is the first tip I have to tell you to understand the mathematical notions behind that. And the second thing is called patience, because there has been, you see, a paper for my research scholar which is in fuzzy logic. You see, I had to read it 7 times to understand what the author is meaning in that. So when you read it many times, many times with patience, say after 3 or 4 times of reading, and whenever you are having a doubt, you have to read again such ebooks, refer Wikipedia, refer good videos like all those mathematical videos that you see in the YouTube. By all those things, patiently you can conquer. And if it is still you are having difficulties, you go directly contacting the expert himself. There is no other shortcut, sir, because we are,
Yeah,
yeah. Because academicians are usually their idea is to frame algorithms, mathematical models. So naturally, their academic papers will be having more mathematics, and the duty of the industry is to take it as a starting point and implement it as a product. That is ideally what is happening in US and Singapore, all those countries. The duty of the academicians is to provide mathematical models to the industry, and the industry people will take those papers and make it as a product. So to understand those mathematics, please follow these tips I told.
thank you, sir. Thank you.
Yes, that's it. Any other doubts? Any other doubts?
Okay, Suraj Kiran. Okay, thank you. All clear. So Utkarsh,
Uh,
thank you, thank you.
so I think so. Like if we don't have any other doubts, like
Okay, okay, fine.
yeah. So so I would like to thank you a lot for such a great and informative session. Like the ideas, how you took us through all the various the deep learning models, the neural network, and the approach to the research papers and journals. I think the participants can agree with me that all in all, this session was really informative and it will be really helpful to each one of us. So thanks a lot for the session.
Okay, thank you very much for inviting me over here. If you have got any doubts, please contact Utkarsh, and you see, he can forward whatever doubts you are having. Utkarsh can forward to me, and you see, it is a very long, deep topic. Sorry that I could not cover all the technical aspects in a very short span of 1 hour. So whatever I could at the concept level, I have shown my maximum sincerity in taking the topic. Sorry if all your depth details were not cleared during this short span of 1 hour. And I am giving you the freedom to contact me for any doubts through email. You can contact Utkarsh for that. Thank you very much.
I just
Thank you. It was a really informative session.
Okay, okay, thank you very much. Bye. So shall I leave, Utkarsh?
Yes, sir. We
Okay,
can. Thanks
great.
a lot,
Okay,
sir.
okay, welcome. Thank you.